Okay, example 2. Suppose you have x cubed plus 2xy plus y squared equal to 7. Okay? And the question is, find dy dx. Meaning you have to find the derivative of y with respect to x. Okay? But the catch is, find dy dx implicitly. And this tag saying that I want it implicitly just means that your final answer is allowed to have y in there as well as x, and that's okay, right? Now, why not explicitly? Well, explicit is better than implicit, right? Because it's clear. But in questions like this, maybe implicit is better. So let me digress a little bit and try to explain why implicit is better in that case. Okay? If we were to actually find the solution of this explicitly, what should we do? We have to solve this for y, right? But solving for y is not that easy. So you have y squared plus 2xy plus x cubed minus 7 equal to 0. And if you look at this equation in terms of y, it's a quadratic equation for y, isn't it? So in order to solve this, you need to use the quadratic formula, which is y equals to negative 2x plus minus square of the b is 4x squared minus 4 times 1 times x cubed minus 7 divided by 2. I guess you can simplify this slightly more by putting the 4 out. When 4 comes out, it becomes 2, 2, 2, 2, all cancels, and you get negative x plus minus square root of x squared minus x cubed plus 7. So that's your y, okay? And because y happens to be two different functions, to find dy dx, you have to write down the solution in two different cases. When y is bigger than negative x, you use the plus. If y is less than negative x, you use the minus. And it's very ugly. Even, I mean, I guess you can actually write down the solution, but the explicit solution is not that pretty. And some people wouldn't like that, okay? So in such a case, implicit is better than explicit, okay? So let's go back. Just for comparison, let's actually just solve this explicitly, okay? Y prime is 1, negative 1 plus minus 2 radical x squared minus x cubed plus 7. It's at the bottom. When you differentiate the inside function and bring it to the top, it's negative 3 x squared plus 2x. And that's the answer for explicit solution, okay? It's very ugly. Okay. Now let's go back and actually find the solution implicitly. Okay, what is this implicit differentiation? What kind of method is it? You just differentiate the equation as it is, while remembering that whenever you see y is secretly a function of x. Okay, it's not really shown explicitly, but it's a function of x. Okay, so we're just going to differentiate both sides. X cubed differentiates to 3x squared, and 2xy has to be differentiated, and y squared has to be differentiated, and 7 has to become 0. Derivative of a constant is 0. Now, the reason I didn't immediately write down the derivative of this is because if you look at this, it's a function of x. 2x is a function of x, right? Y is also a function of x, and these two are multiplied. And what rule should we use? Product rule. Okay, so we have to use the product rule for this one. you have to differentiate 2x times y plus 2x times y prime. Differentiate the first one times the second one. Differentiate the second one times the first one. And the derivative of y is y prime, and that's it. Y is a function of x, so we can't say y prime is 1. Y prime is y prime. Okay? Y prime is really this ugly thing, but we're going to keep it secret. Okay? All right. Y squared differentiates to what? 2y times y prime. Thank you. You need that. Again, that's because y is a function of x, and this prime is d dx. You're differentiating by x. Any questions? If you're confused at this point, maybe I should stress this one more time. What is dy of y squared? 2y, that's it, right? Okay. What's d dx of y squared? 2y plus y prime. Should I explain this again in a different way? Yes. Okay. Let me try this again. What is the chain rule? Chain rule is first of all, if you differentiate y squared as a function of y, that's 2y. That's nothing different than saying x squared differentiates to 2x. Okay. That's not so puzzling. This one, in order to use the Leibniz version of the chain rule to this one, you want to do the following. The Leibniz version of the chain rule is, instead of differentiating this y squared by dx, you want to plug in dy here, but then you put a dy dx multiplied. Why are these the same? Well, in the Leibniz notation, it's kind of clear, right? dy cancels, and you end up with the same thing. Isn't that right? This is exactly the same as the usual chain rule, because this is saying you're trying to differentiate y squared as a function of y, but then y later has to be pulled out because it's an inside function. The inside function has to be differentiated. So this Leibniz form of the chain rule is exactly the same as the chain rule that you used to know, the Newtonian version of the chain rule. Okay? Now what is this again? The same as this one, right? Which is 2y. And then, but dy dx still has to be calculated, right? What's the Newtonian way of writing dy dx? Y prime. So it's still the same thing, 2y prime. All right, so that's why we need this y prime, because over here, when we're trying to differentiate, this prime is differentiation by x. Okay? All right, so we have this, and we get 3x squared plus 2y plus 2x y prime. And by the way, these two have y prime in common, right? So let's factor the y prime. So the way you solve for y prime is the following. You just put everything to one side and just gather the y primes. Okay? And the ones that are not gathered with the y primes move it to the other side. Okay? So we have 2x plus 2y times y prime is equal to negative 3x squared minus 2y. And then finally you divide and that's your answer. So y prime is therefore equal to negative 3x squared minus 2y over 2x plus 2y. Okay? And I claim that this answer is exactly the same as this answer, although they look very different. Okay? If you actually figured out a pair of numbers that satisfy this equation and plug it into here, and also plug it into here, they're going to produce the same exact answer. Okay? And another way to say that is, if you take this solution, y is this thing, right? if you replace this y, these two y's, by this one, and if you simplify, at the end of the day, you're going to be able to simplify it to exactly this. That's my claim. It does give you the same exact thing. And another thing is, if you compare the two, isn't this easier to read, right? The square root immediately turns people off, right? This is a lot easier to read. And probably, if you're given x and y values together, it's easier to calculate this rather than that. That's why we prefer implicit differentiation.